So, you know how you guys have been solving these for x and y like this, algebraically, right? Where you multiply through by something to cancel the y's, and then you cancel the y's and you solve for x, and you get this lovely formula right here. Where does this come from? So, you can solve for x all substitution-like, and this is how we get Kramer's rule. So, I've got d times e. So, notice d is right here. E is right here, minus b times f. That's this guy and this guy. And then in the denominator, we've just got what ends up being the determinant of these four in the denominator. So this is where Kramer's rule comes from. If this doesn't make sense, when I explain how to do Kramer's rule, I'll come back to this, and then this will make a lot more sense. All right, this is like the formula behind it. Okay, so let's do number 1. Number 2, by the way, is changed from the one on your sheet. So, all right. So let's say I want to find x in coordinate x's and y's. So what I'm going to do is I'm going to take the determinant over the determinant. And in the bottom, we always put the original determinant of this 4 by 4 right here. So I'm going to rewrite just the coefficients right here. I have a 3, I have a 2, I have a 4, and I have a -3. So in the denominator is your original determinant. And in the numerator, where this slot is where these x's are. We replace them with the coefficients right here. So I'm going to put a -1 and a 10 in the spots where the x's were when I want to find the x's. And then I rewrite these numbers the same, which are 2 and -3. Okay, and then I just do the determinant. Well, the determinant is this times this, which is +3, minus this times this, which is 20. And in the bottom, I'm going to do the same thing. This times this, which is -9, minus this times this, which is 8. And I get -17 over -17, which is 1. All right, now let's find y. Harrison.
So you start with, the first one is, oh wait, no.
You see it? All right, we're going to do another one too. So in the denominator, you always do the original determinant that's on the left-hand side here. So we just write our coefficients down that are already in these 4 spots. So the same one that I just did. So I have a 3, a 4, a 2, and a -3. And in the top, we keep our same x's. So I'm going to keep these two the same now. So I'm going to keep this as 3 and 4. But this time I'm going to replace the y's with these coefficients right here. So instead of these y's, I'm going to put -1 and 10 in the y spot. And now I do the determinant. So I do this times this, which is 30, minus this times this, which is -4, over this times this, which is -9, minus this times this, which is 8. And I get 34 over -17, which is -2. Okay, and I'm going to write my answer as an x, y coordinate. X, comma, y. So does everyone see where this piece went? So on the x's, it went into the x slot. And on the y's, it went into the y slot. And otherwise, we just wrote it the same. So that's where this comes from, you guys. That's what this formula says for x. You're basically doing the formula for the determinant. And that's all they do. Okay? So let's try this one that's like out of order here, number 2. So the first thing we have to do is we have to put it in standard form. We need all our x's, then we need all our y's, and then we need the number part. So for this part, I'm going to keep the 2x, but this 3y needs to move to the other side. It was a -3y. I'm going to move it over here, so now it's a +3y. And I can keep the 7 over there on the right-hand side. And then this second equation, you guys, what needs to move? Really just the x needs to move over, and it goes first. So it was a positive x. I got to move it over this side. Now it's a negative x plus y equals 9. All right, now we're going to set it up so we can find x using what's called Kramer's rule. So x equals, we're going to do a determinant divided by a determinant. So Ben, can you tell me what goes in this column right here? Good. 7 and 9. And Devin, can you tell me what goes in this column right here? 3 and 1. Good. So remember, these coefficients for the x1 go here. And then in the bottom, we do our original determinant here. And so I'm going to do 2, negative 1, and 3, positive 1. And then we just do our determinant. 7 times 1 is 7, minus 3 times 9 is 27, divided by 2 times 1 is 2, minus a negative 3. And so I get a negative 20 in the top and a positive 5 in the bottom. And so that means for x, we get negative 4. Now, after I get x or y, whichever one you want to find, do I have to do another Kramer's rule? No, you can just do substitution. And this one's a super easy one because if I come back to this one, it's all nice and y is by itself. And I can just plug in negative 4, which means that y is equal to 5 by substitution. And I get the coordinate point x comma y, negative 4 comma 5. All right, so you can just do Kramer's rule once and plug in if you want. All right, don't do this one yet. Okay, what if we have this crazy case right here? So let's set it up and pretend like we're trying to find x. So I'm going to do a determinant over a determinant. And Thomas, what goes in these two spots here on the top? Good. 3 and negative 6. And Anna D, what goes in these two spots here? Good. Negative 2 and 4. And in the bottom, we have our original matrix. So, Maddie, what goes in this whole entire thing here?
3 and a negative 6.
Good. All right. And let's see what magic happens here. So this times this is 12 minus this times this is also 12. And down here I get 12 minus 12. And I get 0 over 0. That does not equal 0, you guys. All right? 0 over 0, you learned in Algebra 1, was called indeterminate. Right? That's what we called 0 over 0. What it actually means is infinite solutions. Can you guys tell me, by looking at these two equations, anything special? Yeah, how do I get from this to this? I times by negative 2. How do I get from this to this? I times by negative 2. How do I get from this to this? I times by negative 2. So I can take this whole thing and times by negative 2, which means what about these lines? They're exactly the same line. And if you graph the same line, like I graph a line, and then I graph the same line, how many times do these lines touch? Yeah, infinite solutions. So if you get 0 over 0, I would like you to write infinite solutions. There's one other thing that can happen if you start doing Kramer's rule. You can get something like 5 over 0. Any number over 0. This one's different than 0 over 0. Okay, what does 5 over 0 mean if it's not infinite? It's no solutions, which means you have two lines that never cross because they're parallel. What that would look like is it would be a multiple, and not a multiple. So it would be like, oh, I'm timesing by 2, but then I'm not on that last part. Okay? So if you solve and start getting that, those are the special cases. Let's try one whiteboard problem.